In this tutorial, we would be looking at the basic programming and of course the tools which are required to burn the programs into the microcontroller. Before that, we need to know the ports in any microcontroller. Here we deal with ATmega8, and ATmega8 has 3 ports, port B, C and D. There are 3 registers associated with every port. The first one is the data direction register, the port input, the port output. Port B has 8 bit or 8 pins. Each can be used for an input or an output purpose. Similarly, C has 7 and 8 for D. DDRX register. Here the X could be replaced by B, C or D. So what is the function of a data direction register? It is used to define the port as input or output. So when we write DDRB or DDRC or DDRD for that matter as 0x00 or 0B0000, depending on the number of ports. For example, for port B it would be 8 zeros, for port C it would be 70 and D 80. So the entire of the port B would or C or D would act as an input port. If you want to make the port as output, you give the value as 1 for each pin. So it would be DDRB in hexadecimal 0xFF or in binary DDRB 0B followed by 8 ones. Now the function of port X register or the port B, C or D register is to give an output value to the corresponding pin. For example, if I write port B as 0B00000011, then port B pin number 0 and 1 would be high, or for that matter it would be the output, and the rest of the pins would be 0 as switch off. The pin X register is used for the purpose of input. So if I write as pin B, C or D as 0B 00000011, so it would read the input from pin number 0 and 1. Take a look at the first program. It is the blinking LED program. For every program, you require the include file. This is known as the header file. The header file includes the description of all the functions which are used in the program. For example, when we say port B is equal to something in the later half of the program, the programming language or the compiler would not understand the meaning of it. It goes back to the header file, takes the meaning from it and passes it on to the function. So here we have two header file, the io.h and the delay.h. We use the define function here as a macro to define the speed of the microcontroller. Here we use a 12 MHz clock speed, hence we define that. So for every program we have the main routine or the main function. A program always starts reading from here. So here first we define the data direction register. DDRB is equal to 0B11. So we are taking port B as an output. Okay. Next we do is we define the while one, which is the infinite loop. It simply means while 1 is equal to 1, you run the program. This would be a true case every time, and this program would run infinitely. Next, port B is equal to 0B, 3 0, 4 ones and a 0, because in our board we have connected the LEDs, output LEDs in port B 1, 2, 3 and 4. So when this state is given, the rest of the pins except for these 4 would be as an output. Would be in a switched off position. Then we give a delay using, we have already defined the header file for delay, and using the delay function _delay _ ms or millisecond bracket 1000, we are giving a delay of 1 second. And then again port B is equal to 0B, all off, so it switches off all the pins of port B, which includes the port B 1, 2, 3 and 4. So your LEDs go off. Once again we want it to be in that position for 1 second, so again we put it as _delay _ 1000. The program would start reading from here. It would see, okay, the user wants port B as an output. It goes further to the infinite loop, comes here, switches on the board, the 4 LEDs on the board, it stays in that position for 1 second, then again it switches them off and it stays in that position for 1 second, and now it would go back. And these brackets are used to say, okay, this is where the infinite loop function is over and this is where the main function is over. This is how it would look in an IDE. Okay, our next purpose of this lab is we are integrating an input and an output. When IR sensor senses an obstacle, the LEDs switches on. But before we go to this program, you need to know a concept known as masking. For masking, we use something known as the AND gate. An AND gate is a logical operator that gives an output 1 if and only if the both outputs are 1. For example, I am interested in reading the value from pin 0 of port C. Then I am not concerned about the inputs of whatever is given in the rest of the values, rest of the pins. So I want to isolate pin 0 from the rest of it. What I do is I make the rest of the pins AND with 0, so they will always give me a value 0 for all other pins. So for example, if there is an floating voltage or an unwanted input in the pins, my input reading would not be affected by it, because even if it's 1, I AND it with 0, my output would always be 0. If this is 0 and with 0, I would get 0. Rest for all. But when you come to this port, the pin 0, what you see is whether if it's 1, I AND it with 1, I get an output 1. If my output is off or my sensor is off, my input is off, output of the sensor is off, then it ANDs with 1 and it gives you an output 0. So now my input reading is solely dependent on pin 0. This is the concept of masking. So let's get back to the program. First here we have the include. First we have the include function io.h, the header file which contains all the meaning of it, of the rest of the functions that we use in this program. Then we have the main. Here we didn't include the header file for delay.h because we are not using the delay function in anywhere of the program. Of course, we are not mentioning even the CPU clock, because now it takes the default value of the CPU clock of 1 MHz. It would not make a difference in this particular program because here we are not using delay function or any other function which relates to the clock speed of the microcontroller. Well, now we go to the main function. Here you see we have defined the output data direction register for port B and the input data register for port C. We have also initialized a value, a integer value named as sensor, int sensor. Next we go to the while one loop. Okay, so the sensor would mask pin C. Like I said, pin C has 7 pins. The port C has 7 pins, and the sensor has to take the value from port 1. So we only mask it with port C, pin number 1. So this is the masking function. Now we have the if loop. If sensor is equal to this, which is if port C pin number 1 is on, I want my 4 LEDs which is in the port B to get on. That would be 0B 000 1111 else I want the port B to be off, which is 0B followed by the 8 zeros, and then I have the brackets closed. So in the development environment, which you'll be seeing further, the program would look something like this. The double hash and the green colored content would not be included in the program. It is known as the comment section. It's always good to mention the comment. Well, for your easiness, we have included the setup instruction of the program in this presentation, but here I would also be showing you how to write and burn a program in a microcontroller. You open your integrated development environment. Here it is the AVR Studio 4. You click on the new project. We are using the GCC compiler. The first program is LED underscore blinking. We click on the create initial file, create folder. We go next. Okay, the AVR simulator, and we take the value of 80 mega 8 because that's the microcontroller that we use. Click on finish. Here, this is the coding section of the program. So for our easiness, I have already written the program. Okay, this is the masking one. Okay, here we have the program. Now, I would click on the build. Okay, so the build is succeeded. Now, what I see is an LED blinking folder on my desktop with a default function and the hex file. This is the file that we would be burning in the microcontroller. So, next I go to the tools and I take out the software which would be used to burn the software into the microcontroller. Run. Yes. So I go to the find device. After connecting my board, it senses the ProjectSansar detected board. I select the hex file which I wish to put in the microcontroller, and I click on the reboot AVR, and when I click the flash device, it would reset the device and you would see the 4 LEDs blinking in your microcontroller board. So congratulations, this is the burning of the first program. So let me repeat the steps for you. Yes. Once again, we go to the AVR Studio 4. We create a new project, AVCC compiler, project name IR output for this case. It's again on the desktop. Go to next, AVR simulator. We take the ATmega 8, click on finish. Okay, I have the programming section again. Okay, here is the program. Once again, I build the program. I go to my desktop. I see IROP folder with the default and the hex file over there. I click on the tool. Once again, okay, if the device is not plugged in, you see device not detected. I plug in my device. I click on find device. It says ProjectSansar detected. Open hex file. Okay, this time I don't want the LED blinking file. I want the IROP file. Click on it. Right? Okay, the reboot AVR is on, and I click on flash device. So now you would see an output whenever there is an input given to the pin 1 of the microcontroller board. Sometimes you might even see an output without the sensor connected. That is because of the microcontroller board floating. So here we have made the connection. This is the sensor 2, which is connected to the PC1. We switch it on and we check our program. So whenever an obstacle comes, the LEDs glow. So we have connected this VCC to VCC, ground to ground, and V out to V out. So whenever an obstacle comes, the LEDs glow. Well, I hope you enjoyed this tutorial. The purpose of the tutorial was to provide an easy learning platform to the students. I wish you to learn and pass on this video tutorial and of course a microcontroller board so that you could learn in a cheaper and an inexpensive way. You could even download the sample programs that we have provided. You could learn more and you could always write us a mail. Please do visit us at www.facebook.com/ProjectSansar, ProjectSansar. Thank you very much.